Dear students, I welcome you to the solution of assignment 12. You must have attended the questions on Six Sigma in supply chain, Taguchi method and robust design, and these were some of the interesting topics that we consider as a part of quality engineering, and you must have tried the solutions. So, like all other assignments, there were 25 questions. Each question carried 1 point, and we had all the objective types question. Only one answer per question is correct. Question 1, determine the signal to noise ratio for the following data 3, 5, 6, 8, 9. So, you have 4 options on the screen: A 2.5974, B 3.8463, C 1.8935, D 4.2182. So, the correct answer is A 2.5974. You can very well see the solution that mean is equal to mu is equal to x1 plus x2 plus x3 plus x4 plus x5 divided by n, which is equal to 6.2, and the standard deviation is given I sigma is equal to square root of 1 upon n minus 1, sigma I is equal to 1 to n xi minus mu whole square, which comes out to be 2.387. So, you have the mean value, you have the dispersion or standard deviation, and if you take the ratio signal to noise, your variability is like a noise, then 6.2 divided by 2.387, so 2.5974 is the answer. Question 2, a company makes bicycles, it produces 450 bicycles a month, it buys the tires for bicycles from a supplier at a cost of rupees 120 per tire. The company's inventory carrying cost is estimated to be 15% of the cost, and the ordering cost is rupees 300 per order. So, here you are expected to calculate the economic order quantity. So, you have 500, 900, 600 and 300 as the choices, and the solution is answer C is correct, that is 600, and you can easily compute it. D is equal to annual demand is equal to 2 tires per bicycle into 450 bicycles per month into 12 months in a year, which is 2 into 450 into 12, that is 10,800 tires, that is the annual demand. Now, if you look at the ordering cost denoted by S, it is given as 300 rupees per order, and H is the carrying cost, that is 15% of 120, that is 18. EOQ comes out to be 600, and your economic order quantity is 600. Question 3, an experimenter has identified 3 controllable factors for a plastic molding process. Each factor can be applied at 2 levels as shown in the table. What will be the optimum combination of the levels of these factors? So, here you can see that factors and levels are given in the table. You have factors like injection, pressure, mold temperature, set time. You have level 1, A1 is equal to 250 psi, B1 is equal to 150 degree Fahrenheit, and C1 is equal to 6 second. You can also look at the level 2 for each factor. A2 is equal to 350 psi, B2 is equal to 200 degree Fahrenheit, C2 is equal to 9 second. So, options are an OA of L8 is suitable, then second is an OA of L4 is suitable, third C, an OA of L16 is suitable, and none of the above. So, you have studied this concept in the lecture and you can recall. So, here the correct answer is B, an OA of L4 is suitable. So, there are 3 factors each at 2 levels, thus an OA of L4 is suitable, and you can see that how various experiments will associate various levels with the factors A, B and C. Question 4, a design that results in products or services that can function over a broad range of usage and environmental conditions is known as product design, quality design, flexible design, and robust design. So, correct answer is robust design. By definition of robust design, a design that results in products or services that can function over a broad range of usage and environmental conditions. So, plasticity of design does not change over a wide range of variation in operating conditions. Question 5. Which of the following is a customer satisfaction oriented benefit of TQM in supply chain management? A. Improvement in product service. B. Reduction in operating cost. C. Reduction in field service cost. And D. Reduction in liability exposure. So, the correct answer is A. Improvement in product service. You can see the elaborated answer that customer satisfaction oriented benefits of TQM are improvement in product quality, improvement in product design, production flow, employee moral and quality consciousness, product service which is part of that, marketplace acceptance. And if you look at the economic benefits or improvements, you can reduce the operating cost, operating losses like rework, rejections and others, reduction in field service cost and liability exposure. Question 6. Which of the following equation is used by Taguchi to calculate SN ratio or S by N ratio when response is to be maximized? The options are in front of you. A, B, C and D is none of the above. The correct answer is B. SNT is equal to minus 10 log bracket E1 by Y square divided by N. Basically it is sigma. So, to maximize the robustness where target performance is the best, Taguchi uses the signal to noise ratio SNT is equal to 10 log Y bar square divided by S square. The second one is the answer which we are referring, and third one, when response is to be minimized, Taguchi uses SNT is equal to minus 10 log sigma Y square divided by N. Question 7. Here you are asked to match the various options. Here match the options as per Taguchi orthogonal array table property. So, 2 level fractional factorial arrays, 2 level array, 3 level array, 4 level array, 5 level array, mixed level array, and on the other side you can see the options A L12, B L25, C L16, D L8, E L50 and F L27. You can carefully see the choices A, B, C and D on the screen, and the correct answer is C. It means 1 is related to D, second is A, third is F, fourth is C, fifth is B, sixth is E. And if you look at the Taguchi's OA experimental design matrix notation, then it is ln 2 raised to k, where n is total number of runs, k is number of factors and 2 is number of levels per factor. So, having gone through the lectures on this topic, you can appreciate this particular question very well. Question 8. What is the goal of the supply chain management? Most fundamental question. Whether to produce value for the ultimate customer, or to reduce organizational inefficiencies, or to make inventory readily available in customer facing positions to fulfill demand, or D, all of the above. Solution is the goal of the supply chain management. The answer obviously is D, all of the above, and the goal is to produce the value for consumer, reduce organizational inefficiency and make inventory readily available in customer facing positions to fulfill the demand. Question 9. Which of the statement is correct regarding Taguchi's noise factor? 1. Design specification come under noise factors. Second, environmental specification come under noise factors, and third, quality specification come under noise factors. You have 4 options A, B, C and D. Both 1 and 2 are correct. Both 2 and 3 are correct. Both 1 and 3 are correct. and D, all are correct. So, the correct answer is B, both 2 and 3 are correct. In Taguchi design, factors that cause variability in the performance of a system or product but cannot be controlled during the production or product use is known as the noise factor. Question 10, GA can only be applied to problems that satisfy. Number 1, the fitness function can be well defined. Number 2, solutions should be decomposable into steps, building blocks, which could be then encoded as chromosomes. The options are A, only 1 is correct, B, none is correct, C, only 2 is correct, D, both 1 and 2 is correct. The correct answer is D. GA can only be applied to problems, as you have learned during the lecture, that satisfy the following conditions or requirements. The fitness function can be well defined. Without this, you cannot look at the improvements. And second, solutions should be decomposable into steps which could be then encoded as chromosomes, which is the very basic mechanism of applying genetic algorithm. Question 11, which of the statement is correct regarding the link between quality and productivity? Number 1, effective quality improvement can be instrumental in increasing productivity and reducing cost. Number 2, the cost of achieving quality improvements and increased productivity is often negligible. A, only 1, B, only 2, C, both 1 and 2, D, none. So, solution is C, answer is C, both 1 and 2, and the link between quality and productivity is effective quality improvement can be instrumental in increasing productivity and the cost of achieving quality improvements and increased productivity is often negligible. Question 12, a tile manufacturing company tests its products according to the Taguchi's orthogonal experiment plan with 7 factors A, B, C, D, E, F and G which may potentially influence the production of defective tiles. The factors were chosen between two extremes like A1 and A2, B1 and B2. The experimental table is given below. Looking at this table, propose the optimal combination of factors. This is really an interesting question, and if you have really gone through the video lecture of the course, then you would identify there are various options given A, B, C, D. You can easily identify that the correct solution is A, that is A1, B2, C2, D1, E2, F1 and G2. Just I am giving you the hint that this part is explained in detail in the lecture, and if you are not clear, please refer the lecture once again. Question 13. How a designer can get maximum robustness of a design? So, you have the options A, by maximizing SN ratio, by maximizing sensitivity to noise ratio, by minimizing SN ratio, none of the above. So, the correct answer is A, by maximizing SN ratio one can maximize robustness of a design. Smallest sensitivity to noise gives better robustness of a design, as we understand. Question 14. Regarding supply chain, which statement is correct? A, information and goods flow in one direction and the money flow in the other direction. B, information and money flow in the one direction and the goods flow in the other direction. C, money and goods flow in one direction and the information flow in the other direction. D, none of the above. So, here I have just elaborated with a small example, and you can see a typical supply chain here which includes component supplier, inbound logistics provider, OEM, outbound logistic provider, distributor, logistic provider, retailer and consumer and end user. And you can see that always there is a flow of goods from upstream to downstream, and in order to plan, forecast better, you must have the information flow as well as the money flow from downstream to the upstream. Question 15. Match the following examples with different factors of robust design. You are given 1 control factor, 2 noise factor, 3 adjustment factor, 4 signal factor, and you have various options like A, operating temperature, B, position of the gas pedal, C, dimensions of parts, D, deposition time in silicon wafer fabrication. And you can see the various options A, B, C, D, and the correct answer is D, which states that 1 is matching with C, 2 is matching with A, 3 is with D, and 4 is with B. So you can spend at least couple of seconds and see that control factors are the dimensions of the parts or type of the material, and design factors that are to be set at the optimal level, noise factor, maybe dimensional variation, operating temperature, humidity, and other factors. Adjustment factor affect the mean but not the variance of the response, like deposition time in silicon wafer fabrication, and there could be signal factor, so set by user to communicate desire of the user position of the gas pedal. Question 16. What is the weakness of Taguchi's method? Taguchi assumes all factors. Taguchi ignores interactions. C. Taguchi considers orthogonal array. D. Taguchi considers noise factors. So the correct answer is B. The key weakness of Taguchi method is its assumption of a main factor only, or it is basically an additive model. It ignores the interactions among the factors. Question 17. Assume you have product with the following parameters: demand 360, holding cost 1, ordering cost 100. What is the total cost for the economic order quantity? You can see the various options, and the correct answer is C, rupees 268.33. You are well aware of the EOQ formula, which is square root of 2 into demand into ordering cost divided by holding cost. You can substitute the values, which gives you 268. Now total cost is demand into ordering cost by EOQ plus EOQ into holding cost divided by 2, as we consider the average holding cost, and this comes out to be 268.33. Question 18. The loss function addressed by Taguchi for variability takes which form, where L is the loss function, K is the constant, Y is the independent variable, M is the specification, nominal value. So you can see the 4 options on the screen, and answer is A, L is equal to K, Y minus M whole square. So loss function takes a common form, which is a quadratic function, L is equal to K, Y minus M whole square. Question 19. The aim of just-in-time manufacturing principle is to eliminate time wastage, labor wastage, cost of excessive inventory, and D, all of the above. The correct answer is D, all of the above. You can also see the elaborated answer here. So GIT aims to achieve zero inventory, zero breakdown, 100% on-time delivery, elimination of non-value added activities, and zero defects. So question 20 is, what are the invisible causes of large inventories? Number 1, workload imbalance. Number 2, work absenteeism. Number 3, machine breakdown. Number 4, quality problems. You can look at the various options on the screen, A, B, C, and D, and the correct answer you can see is that B, 1, 2, and 4. So basically, if you look at the in-process inventory, then in figure, machine breakdown, material shortage, worker absenteeism, these are the factors which basically contribute towards the inventory. Question 21. Which of the following is not an important feature of genetic algorithm? Encoding, fitness function, mutation, or decoding? So the correct answer is D, decoding. You have understood the fundamental steps included in the GA. So encoding, fitness function, and mutation, these are the important issues. Now question 22. Here you are given a small numerical, but it would be interesting in order to revise your concept. Suppose a genetic algorithm uses chromosomes of the form X is equal to A, B, C, D, E, F, G, H with a fixed length of 8 genes. Each gene can be any digit between 0 and 9. Let the fitness of individual X be calculated as fx is equal to a plus b minus c plus d plus e plus f minus g plus h, and you are given let the initial population consist of 4 individuals with the following chromosomes. X1 is equal to 65413532, X2 is equal to 87126601, X3 is equal to 2392128, and X4 is equal to 41852094. Now arrange the individual according to the decreasing order of fitness using genetic algorithm. So you have options on the screen: A, x1 is greater than x2 is greater than x4 is greater than x3, B, x2 is greater than x1 is greater than x3 is greater than x4, and so on. And the correct answer is B, x2 is greater than x1 is greater than x3 is greater than x4. And I am also presenting the complete solution. Fx1 is equal to 6 plus 5 minus 4 plus 1 plus 3 plus 5 minus 3 plus 2 equal to 9. And likewise, when you substitute the value, you will get the values of fx2, fx3 and fx4. Question 23. A great deal of inventory piles up along the supply chain due to poor quality of supplies, poor management of logistics and no monitoring of lead time. C, quality of finished goods may not be high enough to support GIT mode of operation in your customer's operations, and D, all of the above. So the correct answer is D, all of the above. A great deal of inventory piles up along the supply chain due to poor quality of supplies, poor management of logistics and no monitoring of lead time, machines break down, and quality of finished goods may not high enough to support GIT mode of operations. Question 24. Given that the cost of scrapping a part is ₹10, when it deteriorates from a target by plus or minus 0.5 mm, what will be the quadratic loss function for a given m of 0? You can put the values in the quadratic function, loss function given by Taguchi, and easily you can find out the correct option. The answer is C, L is equal to 40 y minus 0 whole square, and you can see the values and how they are substituted. The last question in this assignment is question 25. Under what conditions would you recommend using a compound noise factor? You can see the options: A, when the cost of experiment is high compared to the additional accuracy provided by other noise strategies; B, when the profit of the experiment is low compared to the additional accuracy provided by other noise strategies; C, when the impact of the experiment is high compared to the additional accuracy provided by other noise strategies; D, when the cost of experiment is low compared to the additional accuracy provided by other noise strategies. So the solution answer is A. Noise factors are that which cause a product to deviate from its ideal function. A compound noise factor is a virtual noise factor that determines the setting of several actual noise factors that affect. So it is a compound effect, and a compound noise factor should be used when the cost of experiment is high compared to the additional accuracy provided by other noise strategies. So I have presented the detailed solution of assignment 12, and this must have provided you a very good revision and concept building of the supply chain management, robust design, Taguchi concepts, and so on. So thank you very much for attending to the solution of assignment 12, and subsequently I will be presenting the solutions of assignment 13 and 14.